Hi. Now in today's lecture we will start with a new chapter of organic chemistry, alcohols, phenols and ethers. Right. Now first in this lecture we will look into what are alcohols and phenols, right, and how they are classified and how they are named, right. So basically alcohols and phenols are organic compounds, right, that are derived by replacing one or more hydrogen atoms of hydrocarbons by hydroxyl groups, OH group, right. This OH group represents your alcohol group, right. Now if this OH group will replace hydrogen atoms in aliphatic hydrocarbons, that is alkanes, alkenes, alkynes are aliphatic hydrocarbons. For example, if OH group will replace one or more hydrogen atoms in alkanes for example in methane or in ethane, then we get alcohols, right. Now if this OH group will replace hydrogen atoms in your benzene, right, which is an aromatic alcohol, what we get is a phenol, right. This is your benzene, right. Now we know this, here you have hydrogen atom. If I replace this hydrogen atom with this OH group, what I get is a phenol, right. Now we know if this is your aliphatic hydrocarbon, if I replace, which is a methane, right, this is methane CH4, if I replace one hydrogen atom with OH group, right, what I get is a alcohol, right. So this is your alcohol, this is your phenol, right. So basically alcohols and phenols, these are derivatives of hydrocarbons, right. Since we make them from hydrocarbons, so that means they are derived from hydrocarbons, so they are called as derivatives of hydrocarbons obtained by replacing hydrogen atoms by hydroxyl groups in hydrocarbons, right. Now let's look into classification of alcohols, right. First we'll look into alcohols, then we'll look into phenols, right. Classification is, we can classify alcohols based on the number of hydroxyl groups, right. Broad classification based on the number of hydroxyl groups. If you have one hydroxyl group attached to the alkane chain, right, attached to the alkane chain, we call it a monohydric alcohol because we have one OH group. If you have two hydroxyl groups in the carbon chain of alkanes, we call it dihydric alcohols. If we have three in the carbon chain, we call it as trihydric alcohols, right. So alcohols are mainly alcohols. You have monohydric, you have these dihydric, then you have trihydric, right. Monohydric alcohols is this is your methane. If I replace one hydrogen atom with one OH group, what I get is a monohydric alcohol, right. If I replace, say I have ethane, right, CH3. If I replace one hydrogen atom here with OH and here one hydrogen atom with OH, what I get is a dihydric alcohol because we have two OH groups here, right. So CH2OH, CH2OH, right. This is your dihydric alcohol, right. And remember here this OH group is attached to two different carbon atoms, right. We can, if suppose C2H6, right, we cannot go ahead and attach both OH groups like this, right. We cannot attach both the OH group to same carbon atom, right. Remember, because compounds that are obtained, right, where OH group is attached to this same carbon atom, two OH groups or more than two OH groups is attached to the same carbon atoms, are unstable compounds, right. This would be an unstable compound and it will eliminate a water molecule right, like this, and will change into a carbonyl compound, mainly an aldehyde. It will change into an aldehyde, a ketone, or a carboxylic acid, right? So you will always see alcohols where these OH groups are attached to two different carbon atoms, right? Now coming on to trihydric alcohol, CH2OH, CHOH, CH2OH, right? OH groups are attached to different carbon atoms, right? So remember, OH groups will always be joined to different carbon atoms, and it will never be joined to same carbon atom because of this issue, right? The compound obtained would be unstable, would eliminate a water molecule, right, and will change into an aldehyde, ketone, or a carboxylic acid, right? Remember this. Now let's look into monohydric alcohols. These monohydric alcohols, depending on if this OH group, right, if this OH, we know about primary carbon atom, secondary carbon atom, and tertiary carbon atom. Primary carbon atom is connected to one other carbon atom or no carbon atoms. Secondary carbon atom is connected to your two other carbon atoms directly, and your tertiary carbon atom is connected to three other carbon atoms directly. So depending on your OH group, if it is attached to primary carbon atom, secondary carbon atom, or tertiary carbon atom, your alcohols are primary alcohol, secondary alcohol, or tertiary alcohols, right? We'll just take some examples. This is the primary alcohol, CH3OH, right, where you can see OH is attached to a carbon atom which is not attached to any other carbon atom, right? Now we can have, if this is the alcohol, here you have this OH group attached to this carbon atom, and this carbon atom is directly attached to this carbon atom, right? So this is also 1 degree, this is also 1 degree, or we call it as primary alcohol. This is also your primary alcohol, right? Now suppose if I take another example, right, where this OH group is attached to a carbon atom which is connected to two other carbon atoms, right? This is your 2 degree carbon atom. Why it is a 2 degree? We call it a 2 degree or secondary carbon atom. Why? Because this carbon atom is connected to two other carbon atoms directly, right? Now the OH group which is attached to this type of carbon atom which is connected to two other carbon atoms directly, this carbon atom is your secondary carbon atom or your 2 degree carbon atom. So this alcohol would be your secondary alcohol, right, or 2 degree alcohol. Similarly, if I take another example like this, where this OH group is attached to a carbon atom which is connected to three other carbon atoms directly. This carbon atom is a 3 degree or your tertiary carbon atom, right, and the alcohol would be your tertiary alcohol, right? I hope this classification is clear. First, we have classified based on the number of hydroxyl groups, right? Monohydric, it contains one OH group. Dihydric, where it contains two OH group. Trihydric, which contains three OH groups, right? Now the monohydric alcohols are further classified into primary, secondary, and tertiary based on whether the OH, right, hydroxyl group is connected to a primary carbon atom, a secondary carbon atom, or a tertiary carbon atom, right? So depending on that, we have primary, secondary, and tertiary carbon atoms, right? I hope till this point it is clear, right? Now there are alcohols which are polyhydric alcohols. These are monohydric, dihydric, trihydric. We can have polyhydric alcohols where you have where you have more than two OH groups attached, right, in the alcohol molecule. Now there are some other alcohols where we have allylic, some alcohols like allylic, benzylic, and your vinylic, right? We'll be looking into that. Allylic, alcohols. Now in allylic alcohols, you have allyl system. Right? You have allyl system. Let's take it this side. Right? Now here you can see the OH is attached to the carbon atom, which is connected to this doubly bonded carbon atom. Right? When this OH is attached to the carbon atom, which is further attached to the carbon atom, which is doubly bonded carbon atom, this is your allyl system. Right? And the alcohol, this is your alcohol, would be called as your allyl alcohol. Right? Similarly, this system is your vinyl system. Right? Now if you replace one hydrogen atom, right, with OH group, what you will get is a vinylic alcohol. Right? What you will get is a this is your vinyl system, where you have carbon atoms with a double bond. Right? Now if this OH group is attached to the doubly bonded carbon atom, we call it as vinyl alcohol. Right? Similarly, you have another alcohol which is like this. If this is your toluene, right, and I replace one hydrogen atom of CH3 group with OH, right? These types of alcohol, right, where OH group is present in the side chain, right, these are your benzylic alcohols, and these are aromatic alcohols. These are basically side chain derivatives, right, where one hydrogen atom from the side chain is replaced by an OH group, right? So these are your side chain derivatives. Right? Now if suppose this is your compound where OH group is directly attached to the benzene nucleus, this would be your phenol. Right? When your OH group is directly attached to the benzene ring, right, or it is directly attached to this nucleus, right, this is your nuclear derivative, right, because this is obtained by replacing one hydrogen atom of benzene nucleus by OH group, right. So this is your phenol, right, and you can see these are different than aromatic alcohols, right. So this would be phenol. Phenol is where OH is directly attached to the benzene ring, like here, right. Now these can be further divided or these can be further classified, right, if it has one hydrogen atom, if it has one OH group, two OH group, or three OH groups, right. For example, let's look into it. If you have this like this, you can see the position of OH is changing, right. So since it contains two OH groups, right, these are your, we call these as phenols containing two OH groups, right, and both the OH groups you can see are directly attached to the aromatic ring, right. These are known as dihydric alcohols. This is a monohydric alcohol. These contain two OH groups, so this is a dihydric alcohols, right. Similarly, we also have trihydric alcohols, where OH group is connected, where three OH group is directly connected to your benzene ring, right. For example, this right, or this is also, these are your trihydric alcohols, right? And you can have this type of alcohol as well, right? All these are your trihydric alcohols. And remember one thing, that these trihydric alcohols, how do you name these? Name these 1, 2, 3, right? Just note the position 1, 2, 3, 4, 5, 6. So this would be 1, 2, 3 trihydroxy benzene, right? And the other one is your 1, 2, 4 trihydroxy benzene, right? We are just differentiating the compounds by the position of OH group, right? This is your 1, 2, 4 trihydroxy benzene, right? And by general names we call this as pyragalol, the first one, right? This one, the one that I've mentioned the first time, this one, this is your pyragalol, right? And the one which is your 1, 2, 4, that is your hydroxyquinol, right? And the third one, this one, 1, 3, 5, 1, 3, 4, 5 trihydroxy benzene. This is your, we call this, the general name is fluoroglucinol for this, right? Similarly, even these dihydric alcohols can be named. This is your catechol, right? This is your resorcinol, right? And this one where you have OH groups, this is orthodihydroxybenzene. This is your para, this is your orthodihydroxybenzene, this is your metadihydroxybenzene, and this is your para, because both the OH groups is in para position. So this is your para dihydroxybenzene, right? The general name is your quinol, right? This is catechol, this is meta isomer is resorcinol, para isomer is quinol, right? I hope this is clear. Now let's look quickly into the nomenclature of alcohols and phenols, right? In nomenclature we would be looking into the common system, right, trivial system, and your IUPAC system, right? How to name these alcohols, right? Now it's your nomenclature. First is your common or trivial system. In common or trivial system, these are named as alkyl alcohols, right? In common or trivial system, you will call these as alkyl alcohol. For example, CH3OH. Just know what alkyl group it is and then add alcohol to it. This is your methyl alcohol, right? If you have this C3H7OH, this is your propyl. So name would be propyl alcohol, right? This is your common system. In common or trivial system, just add alcohol to methyl, to alkyl group. These are named as alkyl alcohols. First write down the name of the alkyl group, looking here, right, and then mention alcohol, right? It is simple. The other is your, in alcohols we have a system called as Carbonyl system. We have a Carbonyl system. In Carbonyl system, alcohols are named as derivatives of methyl alcohol. And derivatives of methyl alcohol is your carbinol. What is this carbinol? Carbinol is nothing but your methyl alcohol, right? So these are named as derivatives of carbinol, right? And carbinol is your methyl alcohol. Right, now let's name some of them. If this is the compound, this is your methyl alcohol, so we will name it as carbinol only. Right, now if I replace one of the hydrogen atoms, right, with the methyl group, right, let's say we'll replace this with the methyl group, it will become this. So this would be, this is a derivative of carbinol, we will call it as methyl carbinol. Right, if I replace this with say ethyl, so it would be ethyl carbinol. Right, so this system is not much used. This is an old system and now it is replaced by your IUPAC system. Mostly IUPAC or your this common system is used. Right, this one is less used. So if I have say, I have to name this as per carbinol system. How will you name this? Right, you have 3 methyl groups, right, and I have obtained it from this methanol, methyl alcohol, which is carbinol, by replacing 3 OH with your methyl. So this would be trimethyl carbinol. Right, this is how you will name it. The third one is your IUPAC system. Third one is your IUPAC system. Right? In IUPAC system, suppose this is the compound methane. In methane, you will minus E, you will replace E with OL. Right? OL. You will replace E of hydrocarbon with OL to name it. Right, so this would be, if I replace E of methane with OL, it will become methanol. So this is your methanol. Right, similarly, if I have C2H5OH, how will I name it? This is derived from your ethane. Right, so I will replace E with OL, it would be ethanol. This is how you will name it as per IUPAC naming system. Right, and suppose you have this dihydric alcohol, the one that we have studied sometime back when we were studying about classification. How will you name it? This is derived from ethane. Right, since this is derived from ethane, we will call it as ethane. Since these OH groups are at different carbon atoms, 1, 2 say, we will name it as, in IUPAC system, ethane 1, 2 diol. Right, this is named as ethane 1, 2 diol. Right, similarly, if we have say propane, derivative of propane, CH2OH, CHOH, CH2OH. Right, this is your propane, CH3, CH2, CH3 is propane molecule. So one hydrogen atom at all 3 carbon atoms are replaced by your OH group. Right, so this has become propane 1, 2, 3, 1, 2, 3 triol. Right, I hope this is clear. This is your naming convention of alcohols, right? So till this point, I hope this is all this is clear. Now in the next video lecture, right? In the next video lecture, we would be looking into the structure of alcohols and phenols. Thanks.